All right, so today we are going to be looking at vector quantities, okay? Now, vector quantity is a very important topic in physics, in fact, in science, okay? Vector quantities cuts across uh, mathematics, engineering, and then physics, and other science subjects, all right? So, as a student of science or as a science student, you are supposed to be familiar with vector quantity because a lot of the quantities you'll be coming across or you'll be dealing with in science, majority of them are vector quantities. And as such, you should be able to add vector quantity, should be able to subtract, and solve problems, especially when they are inclined at angles. All right. So, in just very few steps, I'm going to be summarizing vector quantities. So, the much we can take today, and then in our next video, we are going to finish up the rest and then try to solve past questions in vector quantities. All right. So, I will start by defining vector quantity. What is a vector quantity? A vector quantity or vector quantities are quantities that have both magnitude and direction, okay? So they can be measured and then they have direction. What are examples of these vector quantities? They include force, weight, tension, upthrust, velocity, acceleration, momentum, and the rest of them. There are so many of them, all right? So all these are vector quantities. Now, how do you represent a vector quantity? A vector quantity is represented with a line and an arrowhead, okay? The line showing the magnitude of the vector and the arrowhead indicating the direction of the vector. All right. Now, from there, we move into addition and subtraction of vector. For vectors, you don't just add or subtract like scalar. So for vector to add or to subtract, you do that vectorially, following the formulas and then following their direction of movement. Okay. Now, if we have, let's call this one vector A, and we have another vector B moving in the same direction as A. Okay. If you want to add this vector, the resultant vector, we call the combination of the two resultant vector. The resultant vector, which is R, is going to be A plus B because they are moving in the same direction. Let's assume that vector B is greater than vector A. If vector B is greater than vector A, the direction is going to be in the direction of B. And the direction of vector B, okay? Now, if they move in opposite direction, this is when they move in the same direction. This is for when they move in the same direction, right? So when they move in the opposite direction, when they move in opposite direction, let's assume vector A still maintaining its direction in the eastward, and then vector B is changing direction westward, in the west direction. The resultant vector here, R, is going to be B minus A in the direction of vector B, in the direction of vector B, or in the west direction. All right? So that is just it. This often is not usually a problem for students. Where the problem comes in is when the vectors are now inclined at an angle. So lest I forget, when the vectors are equal and they are moving in the same direction, their resultant is going to be, they are moving in opposite direction and they are equal, the resultant is going to be 0. Okay? Now, let's take when the vectors are inclined at angle. When the vectors are inclined at angle to each other. So we call that inclined vectors. So let's take case one. When the vectors are inclined at angle 90, are perpendicular, i.e. at angle 90 degree to each other. We make use of Pythagoras theorem and trigonometric ratio to find the resultant vector, and then the direction of the vector. We use trigonometric ratio to find it. So we make use of Pythagoras theorem to find result, and Pythagoras theorem says a squared equals b squared plus c squared. In physics, we say r squared plus f1 squared plus f2 squared. All right? Or you can put it like this, that r is equal to square root f1 squared plus f2 squared. These and these are just the same thing. Then you can use trig ratio. In trig ratio, you involve SOHCAHTOA to find direction of the vector. In trig ratio, trigonometric ratio, trig ratio involves SOHCAHTOA. All right? So you can use sine, can use cos, can use tan to find direction. So we are going to take example now. For example, if we have two vectors inclined perpendicular to each other, this one is moving north and this one is moving east. All right? Now, here, their resultant is going to come from their common point of intersection. Their resultant, if we call this one F1, this one become F2. The resultant is this, okay? And it's coming from their common point of intersection. This is following a law which we call parallelogram law of vector addition. We are still going to state that law as we continue. So to find the resultant, you use this formula to find resultant. Okay. Now, to find the direction, this resultant is between the north and the east. You find direction with respect to two reference points, either the north or the south. Okay. So when the resultant, you find direction of resultant with respect to either north or south. Now, in this case, the resultant is between north and east. So you are finding the angle. The bearing of this resultant is going to be the angle between the resultant and the north pole. So I can decide to call the angle alpha. All right, I can decide to call it alpha. You can decide to find this angle, the angle between the resultant and the east. When you get it, knowing that from this point to this point is 90 degrees, you minus whatever you get here from 90 to get the angle here. So you can as well solve it that way to find the direction. So if I decide to use tan alpha here, tan alpha is now going to have, tan is opposite over adjacent. The opposite here is F2. Here is also F2. If here is F2, here is also F2. If here is F1, here is F1. So tan alpha is going to be opposite, that is F2 over adjacent, which is F1, to find the direction. So if you use this, you are going to find direction. Okay? So now let's look at when the vectors are inclined at angles that are less than 90 or greater than 90. Angles that are less than 90 are referred to as acute angle, while angles greater than 90 are referred to as obtuse angle. All right, so let me take one example here. When the vectors are inclined at angles that are less than or greater than 90 degrees. Here, we make use of what we call cosine rule to find the resultant, and then sine rule to find the direction. We use cosine rule and sine rule to find resultant and direction respectively. Okay, we use respectively. We use cosine rule and sine rule to find resultant and direction respectively. All right, so what is cosine rule? Cosine rule says that r square equal to f1 square plus f2 square plus 2f1 f2 cos theta or cos alpha, as the case may be. You can use anything to represent the angle. Why sine rule says that sine of angle A all over the opposite small letter a equals sine angle B all over the opposite small letter b equals sine of angle C over its opposite small letter c. Okay, so these are the formulas you use to find the resultant and the direction. So let me take one example here. For example, we have two vectors inclined at angle 50 degrees. Let's say we have two vectors, one in the east direction, and the other one in the northeast direction. So let me call this one F1 and let me call this one F2, and the angle between them is 50 degrees. Okay, now to solve problem here, I told you earlier there is a law we follow to solve problem here, and that law is what we call parallelogram law of vector addition. And what does that law state? That law states that if two vectors represent the two adjacent sides of a parallelogram, both in magnitude and direction, the diagonal drawn from their common point of intersection. So this will be the diagonal drawn from their common point of intersection represents the two vectors both in magnitude and direction. I come again. It states, if two vectors represent two adjacent sides of a parallelogram both in magnitude and direction, the diagonal drawn from their common point of intersection represents their resultant both in magnitude and direction. So we can complete this parallelogram so that we are going to have something like this, and then we have something like this. Okay, so this is a parallelogram. This side and this side are equal, so here is F2. This side and this side are equal, so here is F1. Okay, so that is it. Now, to solve your problem, to find this result, and you use sine rule so that you now say r square equals to f1 square plus f2 square plus 2f1 f2 cos theta. Or you can as well use r square equal to f1 square plus f2 square minus 2f1 f2 cos bracket open 180 minus theta, where theta is the angle between the vectors. Okay, in this case, the angle between the vectors is 50 degrees. Okay, so you can use any of this. Then after finding it, you now find the direction of this resultant with respect to north pole. Remember, I told you that direction is always found with respect to either north or south. If this resultant vector is between east and south, we'll find the direction with respect to what? To south pole. But in this case, it is between north and east. All right, so to find direction here, we are going to say for direction, before we will be able to do that, here you don't just go direct and find direction. You first and foremost find the angle here, the angle between the resultant and the east. I can call it alpha. When you get it, you now minus, knowing that from here to here is 90 degrees. When you get this angle, you minus it from 90 degrees to get the angle between the resultant and the north pole. That is the angle from here to here. So when you found alpha, you minus it from 90 to get the angle from here to here. We can as well call that angle beta. Okay. But before you were able to find the resultant here, you need to extrapolate. You need to find the angle here. You need to find this angle. Okay. If the angle between the vectors, that is from here to here, is 50 degrees, it then follows that the angle here also is 50 degrees, because the angle here and the angle from here to here are the same. And if that's the case, the angle inside here is going to be 180 minus 50 degrees, which is going to give us what? 130 degrees. So the angle here is 130 degrees. So that if you label here O, A, B, C, you can actually cut out OCA or OAC there to find the angle from this point to this point, and whatever you get, you can now say that you can use beta equal to 90 minus alpha to find the angle from here to here. Okay, so I'm going to stop here for today. In our next class, I'm going to complete other problems that we might have under vector quantities. We solve after completing it, derive some other formulas, because we still have resolution of vectors, component vectors, and then we have resolution of vectors that are more than two. That is when you have many vectors, how to resolve it. So I will do that one, and then we solve problems and as well look at past questions into it. So thank you so much. Please comment, like, and share. All right. Follow me also on YouTube. My YouTube channel is perfect_tutor/academy. Then I have TikTok channel as well. There you see it is Perfect Tutors Academy. Thank you so much. Comment, like, and share. God bless you.